Hi everyone.
Good morning.
Right. So let's give people a few more minutes to join in. Uh, let me share some things that which is I uh, supposed to complete it a little bit earlier, but um, I did not. So I'm apologies for that. Um, so this is the kind of a small notes that as we had a chance to meet in person after the Global Summit uh, workshop on last Wednesday. Um, we had a chance to meet in person on Thursday morning, and we're discussing that uh, we should expand the existing white paper with a little bit more discussion about the 400G and kind of take quick notes about uh, w- the things that we discuss on Thursday, and I I definitely missed some things, and just please help me to complete the complete this outlines, or if you already start working on the contents, that would be wonderful. And please take a look, see if anything was missing. The first was not related to 400G. It's more about the data center densification. The only things I was remember when they was talking about wanted to have more fiber bundle instead of maybe 10 or maybe 12 or 24. Um, the fiber bundle can be included more fibers because that will reduce the amount of work to implement in the data center, but that also create many challenges over there. So I think that will be a good topics uh, to talk about because that's the things that we usually don't know unless you actually working on the data center setup. Um,
Bobby, I'm sorry. I need some context. Is this chart you're showing, this Word document, is this an augmenting the existing outline to include a section on 400G, or is
uh,
Or is this
Yes,
changing the whole
yes.
white paper to only focus on these topics now?
That's the extension. So
Extension. Okay,
yeah, yeah.
thank you.
Michael, I could give an idea from my side. So the discussion we were having was, the white paper is a bit late, from the industry, and where the industry's focus on is, today the AI systems are probably like, 200 or 400 G pipes point to point. And in the future, they're going to need to get to 800 G pipes. And, that can be done as, native, 400 Gs or multiple 100 Gs or, whatever it is. So the real question is, if we really think forward, we want to be more of a thought leader in it. Thinking about how to fill these bigger pipes, how to do this bigger pipes. What are the trade-offs involved? What do you have to do to get the density that, like Dave would do? That's kind of I think the
Fully,
direction.
yeah, thanks, Jeff. I mean, fully understand. The NVLink port is a 400 gig port. It just happens to be
Exactly.
carried on two 200 gig physical
Yeah.
lanes. So yeah, absolutely.
So
Agreed.
then, the idea was that, we had different people like Dave Peeler, would talk about what would happen in the data center. I think Dave would also take a look at, I think some of the VCSEL related technologies or something like that. I think if I remember correctly, we'd look at some of the newer technologies like TLFN and other things and how they might fit in. So basically just flesh out that area for, how to get more data, bigger pipes, and make that work for scale up.
For sure. Thanks.
Yeah. Thanks, Jeff. Thanks for the clarification. So that was one item that I think it isn't 100% related to 400G, but that was an interesting topic. Should put it into the white paper. And then for the 400G part, we have thing Raymond was agreed to expand the discussion a little bit more on just 200G versus 400G, and then some of the um, copper connection trade-off between the PAN 4 and PAN 6. And they also agreed to working on the optical part. I think that's very thanks for. I wrote down the SerDes requirement for PAN 4 versus PAN 6. I think that was one of the brief discussions that we had. I don't know if we want to uh, address this item or not, because this, I think it was Eric brought it up about the difficulty of the SerDes design compared with PAN 4 versus PAN 6.
Yeah, that one actually, when I saw it just a few minutes ago, I have a question mark there also because I'm not sure in this group we actually have a representative from IP design company.
Mhm.
It can take a little bit deeper if any. I don't know other people, but just speaking for myself, it can be a little difficult to find information. That
Yeah.
being said, I remember early this year during DesignCon,
Mhm.
SNEA SFF did a 400G workshop, and Synopsys and Alpha Wave got bought by Qualcomm. So it's now Qualcomm. They both, if I remember correctly, they both say that PAM6 is achievable. No detail, but they say it's okay. Just a side note.
I thought it was more that PAM4 was supposed to be difficult on the copper side.
Is no from the 30 design perspective, it's just not a problem. They can do PAM4. The trouble is once it get out of the 30, how far can it go on electrical on
Yes.
copper?
Yes.
PAM6 puts some new complexity to the 30, but they don't think that is something insurmountable.
Yes, exactly. So I didn't hear that there was, I see that's the second bullet under electrical, right? But this second bullet under optical, is that really, was that a SerDes requirement for PAM4 versus PAM6? You're talking about gearbox? Because why other else would this be under optical?
Because as far as I record, is probably uh what what makes it difficult for optics to drive PAM6, right? And what is the additional SerDes requirement to in order to make uh in order to make optical drive at PAM6? Because I think I remember what I recall was the in more straightforward, people always said, hey, PAM4 is better compared with PAM6 because the signal to noise ratio, you got larger eyes, you got that's fairly straightforward. Um, but um, but why um, wh if copper can live with PAM6, why not? Why optics wanted uh, to go with PAM4, even though it is possible to drive at PAM4. Why can't we just live at PAM6? And I recall something about like the additional SerDes requirements that for for op for the optics SerDes to drive at PAM6. Um, and And I think that's probably why I put down a note over there to remind myself to put it in. So I don't know. Is this the part that it's should we even spend time to think about this or
I don't know that we know that David isn't already covering that. I just think this might be getting into
Mhm.
more detail than
Yeah,
Well,
all
I
right.
think it isn't the issue more about it's just more about what the penalty is for optics if you use PAM6 versus PAM4. I mean, I think that's essentially the question, right? Not about SerDes requirements, but just what's the penalty if you try to
Okay.
use PAM6 instead of
Uh-huh.
PAM4.
Okay. So I would put the
And I think there's a lot of information about that.
mhm.
So Bobby, is this document in the white paper directory?
Yes, I put it in here.
And do you know what's it called?
I put as a V0.3.
Got it. Okay.
Yeah. Um, oh, so by the way, I sum up with the all the white paper contribution into one big Word doc in here, which is using the OCP document template as a base and pulling all the content inside. So right now the format is disaster. I uh, just try to get everything into one file and try to read through it to see how we can organizing the story better and find out if there's any missing items in there. So it's not complete yet or any sort of the ready to be review uh, state. But please uh, just go through read through it. I'll continue. I'll constantly update when I fix the formats or other things inside. And if you have any comments, please put it down, and we can all work for it together. The downside of it is it has to be open by the Microsoft Doc instead of Google Doc in here. So the um, the comment features, unlike all these Google Doc things, has a very easy tracking the comment and revision. When you use the Microsoft one, may not be that easy uh, to naturally co-working together. Um, so I hope there uh, there isn't any things that's gonna step on each other's toes. So I don't know if we should um, have each everyone, if you need to make some modifications or comments, should we just download it, and once you finish, you can upload a new one, and then just put put a name or a time stamps on top, um, so so uh, s- we don't work on the same one and overwrite each other's work. Just uh, random thoughts about the working at a G drive versus a OneDrive things. Okay. So go back to okay. And then and I think this one is what Jeff brought it up at that day, talking about what would be the physical picture that uh, when copper switched to the optics would looks like, especially uh, with the CPC, how these copper cables gonna be a big bundle. If that happens inside the case or it happens just on the substrate, what would that be looks like? So just give the reader a picture of uh, what is the difference, between the CPO, MPO, and pluggable, um, when with different format, and not just only one lane, but when you're talking about hundreds of lane, what would be the main difference would that be? And potentially, I kind of add these things inside to compare the different backplane design, and if using the uh, different scheme of the um, uh, optical format. And I think there was one lines that we're talking about different SerDes for scaled out versus scaled up. I don't know if this one makes sense, um, but I just put it here first. And the very last one was the single single lane 400G versus multiple lanes in 200G to implement 400G. And I think Eric mentioned about even now implement the 200G still have plenty of challenge to need to be overcome. And I don't know if we want to bring up all the bring up this part in the session. This is the part that I also not sure about the storytelling part.
Hey, Bobby, I remember. So okay, so I'm looking at the third bullet under the 400G development, how
Mm-hmm.
copper and fiber work together. I remember last Thursday morning when we had a face-to-face discussion, we actually, if I remember correctly, we all of us kind of nod our head and agree that we don't want to get into the details of the what I call the physical architecture,
Mm-hmm.
how any specific company, doesn't matter Dell or HP or Supermicro, build their interconnect, but more like stay with a higher level, maybe just two category that is very broad. One is just a backplane and one is the pluggable. And within these two, if we do 400G, let's say PAM4, how long can the copper be? And then where the fiber need to take over. If it is PAM6, how long the copper be, and where the fiber needs to take over. I think that is a very clean, without too much detail, and it's something that is not too big that we cannot finish within the next 3 months, something like that. Is it how you picture that part would be?
Yeah, I'm picture this part should be a quick one to finish. Um, and I think we discussed a lot, so I may not capture all the details. That's why I think you know to gather everybody's mind is great. So you can fill in the blank that I um, did not capture in my notes. So I think that's probably part of the things that you mentioned is correct. The picture. So how can I add that things into here? More like in 400G interval between uh, and thing to optics.
Um, So this is Mike. Could I say
Yeah, yeah.
something?
Of course, yeah.
Yeah, I mean, I think that it's very important for the white paper to talk about the electrical interconnect to the optics,
Mm-hmm.
but pushing this white paper into electrical channel modeling and connectors and exiting BGA packages and all that kind of stuff is, I think, I mean, it's not where I would think we'd want to go. Otherwise, it becomes a massive expansion, in my opinion, to the scope of the activity, because that's a whole nother field.
Mm-hmm.
So I would be cautious about doing electrical channel modeling in the context of this white paper.
Hey, Mike, I just put something in the chat, a graph I created that I thought when we were talking about this at Thursday, this is sort of kind of the thing I had in mind, but I created it afterwards. I don't know. So this is how I think about it. It's really about, what are the trade-offs with the reach of the copper versus the power consumption, especially for scale-up links since there's so many of them. I think that would be okay for us to tackle.
Okay, this is not channel modeling. This is sort of a summary.
Yeah, I think that's the level we want to be at for the paper.
Well, that's different, yeah. So that maybe rephrase that bullet item, summarize the 400 gig electrical channel capabilities and how it relates to the optical solution.
Yeah, Michael, I think you and I are saying the same thing actually, because I have no intention to try to get into all the detail of the electrical channel modeling. I wouldn't have all the model anyway. It is more like based on what we already know, depending on PAM4 versus PAM6, what is the expected length a copper channel can support. And then from there, fiber needs to take over. Which is like what we think that we don't want to get into the detail of the architecture. That's a given. Different company do things differently. It's up to them to do it. But from a white paper perspective, we can give some information and guidance. If you are doing 400G, if it is PAM4, expect your copper channel to run out of steam around this long. Something like that, and people can start to think about where to drop in their optical engine and switch to fiber. That's the motivation, without too much complications. Yeah.
I think summarizing is fine. I just don't think we want to get into the business of modeling the electrical channel and everything that goes into that. Jeff, can you describe your chart? I'm having a little trouble understanding it.
Well, so the idea is there's about 10x the amount of scale up as there is scale out.
Okay.
And when you do these links, you can, do everything from co-packaging to fully retimed pluggable modules. And, it's well known in the industry what the picojoules per bit is for each of those solutions.
Yeah.
So if you take a rack that's modeled loosely after the NVIDIA rack, NVL72, and you just then count up the power for scale up and scale out interfaces within that rack. Because what it's showing is that your choice between retimer architectures for scale out has a pretty minor impact on power. The dominant impact on power, of course, will be the scale up interfaces because there's so many of them and both ends are inside the same rack. Does that make sense?
So the blue line on the bottom, it says scale up CPO. So that's physical instantiation. You put a CPO element inside the chassis on the chip.
Yeah.
CPO, and then the CPO module can be retimed, LTLR,
Well, no, I'm sorry. So CPO would be the far left, and then or whatever, that's CPO one. And then the next one would be like an LPO, that would be non-retimed, has a little bit higher power dissipation.
So
And
I
then
just want to follow, I just want to follow the blue line that's labeled scale up CPO.
Mhm.
What do the four dots mean as I follow the blue line from the left to the right?
So the blue line itself is for CPO for scale up, and then the dots represent the points for the scale out retiming architecture, right?
Okay.
So the scale out could be done with CPO on the far left, or it could be done fully retimed on the far
Okay,
right.
fine. You're saying, okay. Yeah, the fact that all the lines are flat means scale out has a negligible impact on the whole power. Okay,
That's
fine.
right. That's right.
Okay, understand. So the four lines, blue, orange, green, and red, just are the power of the scale up optical interconnect.
Right. That's right.
Okay, got it. Sorry for the confusion.
And by the way, Jeff, the vertical axis say additional interconnect power. So what is the reference? So basically, what is zero?
Well, zero would be if you use a passive copper cable and only went a meter.
Okay, so zero will be, so you are referencing everything to copper interconnect.
Right.
Okay. And the additional power is measured by kilowatt.
Yeah. That's right.
Wow.
Yeah. I mean, it's
Okay.
very significant, right? I mean, I think this is the kind of thing that would be useful in this white paper, right?
Yeah, definitely.
So even the lowest one doing CPO, we're still talking about 4.25, 4.3
Something like that.
kilowatt
Yeah.
additional power. Ooh,
Hmm.
thank you.
Yeah.
Sure.
Oh, you're putting in the chat.
There may be a better way, Michael, if you have a better idea of how to get the point across, but that was my thought.
I didn't see it in the chat until now. Try to open it up and view it.
Yeah, I think we're gonna have to go, isn't it, after 8 already, or whatever time.
Yeah. So I think it's about time. So we'll continue working on it. If you have some thoughts, please update it. And also the Word doc is on the drive as well. Please help me to review.
And then I think just as a set expectations, Bobby, I think we talked about maybe trying to be done with this, but in January or something, some timeline like that.
Yeah, yeah. Please, hopefully, we can get everything done by the end of this year, and then we will go through the paperwork and other things to publish it, finished by January.
Perfect. Thanks.
All right. Thank you, everyone. We'll see you next week. Bye.
Thank you. Bye-bye.